Hello guys, welcome back to learning microcontrollers. In this video, I'm going to show you how you can interface a PIC16F877A microcontroller with an LM35 temperature sensor using 16x2 LCD, and I will be using the hardware demonstration to show you how this works. So guys, uh, in this video I'm going to give you sensor formulas like how you can display the sensor value on the GHD 16x2 LCD, and you will be converting the sensor formula into Celsius and Fahrenheit. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. This is the LM35 DC sensor I'm going to use. This sensor has 3 pins, as you can see. Left one is a VCC, center one is a ADC, right one is a ground pin. Now guys, to connect it with a PIC, you will connect the ground pin directly with the ground pin of the PIC, VCC with the VCC pin of the PIC, and ADC is the ADC pin. For that, you can use any available ADC pin of your PIC. I am going to use the pin number A0. Remember that from where the writing starts on your sensor, that is the VCC pin, and where there is L, remember that where there is L written on the sensor, that side, the pin at that side is the VCC pin, while the pin at the right side where 5 is written, that is the ground pin, and the center one is the ADC pin. Now guys, to display the output, I am going to use a 16x2 LCD. To adjust the contrast of this LCD, you will need a potentiometer 10 kilo ohm. Now guys, let me show you how to connect this as well with the PIC. This potentiometer has 3 pins, 1, 2 and 3 like this, and this LCD has 16 pins, 1 to 16 from left to right if you hold it like this. So you will connect the pin number 1 and 5 of the LCD with the pin number 1 of the potentiometer, then send it to the common ground. Then guys, pin number 3 of your LCD is a contrast adjustment pin. You connect it to the adjustable pin of your potentiometer, that is the pin number 2. Now guys, pin number 2 of your LCD is the VDD pin. You will connect it to the pin number 3 of the potentiometer, then send it to the common VCC supply. This is, in this way, your LCD will get the 5 volt and your potentiometer will get the 5 volt. Now guys, pin number 4 is the RS pin. You can use any available digital input output pin of your PIC to connect it. I am going to use a pin number C0 for this, that is pin number 15. For pin number 6 of the LCD, that is enable pin, I am going to use a pin number C1. For pin number data 4 of the LCD, that is pin number 11, I am going to use a pin number C2 of the PIC. For data pin 5 of the LCD, I am going to use a D2. For data pin 6, I am going to use a D3 of the LCD. For data pin 7 of the LCD, that is pin number 14, I am going to use a pin number C4 of the PIC like this. Now guys, pin number 15 and 16 of the LCD is only to be used in case your LCD supports a black light. If your LCD don't have a backlight, then you will not use these 2 pins at all. So my LCD do have a backlight, so I'm going to connect the pin number 15 to the VCC and 16 to the ground like this. Now these 4 pins, pin number 7, 8, 9, 10, they are for the 8-bit mode, while we are using this LCD in the 4-bit mode, so we don't need them. Now guys, what's going to happen is that this LM35 will send the ADC data to the PIC microcontroller like this, and then guys, our PIC will process the data as per our programming, then it will display the value of the LCD. Other than this, I will also be using this LED to display that whenever the temperature goes above a certain value, LED will turn on as a warning. So guys, let me show you how to connect this LED as well. It has 2 pins, one shorter, one longer. Shorter pin is the ground pin, connected directly to the ground. The longer pin you will connect it to the any available digital input output pin. I have D0 available, so I am going to connect it to the D0. Now guys, the top line of this LCD will display the temperature in Celsius. The bottom line will display the temperature in Fahrenheit like this. Now whenever the temperature, I will set a certain benchmark where whenever the temperature goes above 30, then the LED will turn on. When it will go down, the LED will turn off. So this will be a simple mini project. So let me introduce you to the hardware as well before we continue. So let me power off the PIC. So guys, this is the hardware we are having here. It's our 16x2 LCD. This is the LM35 sensor I am going to use. It is connected as shown in the presentation, and this is the PIC16F877A microcontroller, and these are the 3. This is the LED. I am going to use this one. So guys, let's get to the programming. So this is the MIKROC version I am going to use. Let me zoom in for you. So 7.2.0 is the one I am using. I suggest you use the same or higher because higher versions are better. Click on File, New Project. It will lead you to this window. Then write the name of the project. I write LM35 JHD Learning Microcontroller Tutorial 1. PIC16F877A is the microcontroller I am using, and 20 MHz is the crystal I am using. Click on Next, Finish. So guys, this is the window we receive. Now first of all, go to the right, and before that press Ctrl S to save your project. Save the project wherever you prefer. Now go to the right. In the right side you will have this library manager expanded, and select the libraries you are going to use in this project. We will need the ADC library for the LM35 sensor conversion to convert the sensor receipt value to a string, because we cannot display integer and float directly on the LCD. So we will need to convert them to a string to display them on the LCD, and then we will need the LCD library, and that's all. So first of all, we initialize the LCD. For that purpose, expand the LCD library. Here you have LCD INIT command, this one. Go to this command, and in the example below you copy these lines till here. Don't go below that, only till here. Then you paste it above the void main like this. Now guys, as shown in the presentation, for the RS pin, we had selected pin number C0. For EN pin, we are having C1. For D7 pin, we are using C4. For D6 pin, we are using D3. For D5 pin, we are using D2. For D4 pin, we are using C2. Now guys, if you have other pin configuration, the only difference will be you will have different pin layout here. You will simply change this pin. If you are using a different pin for the RS, just write that pin. If you are using this different PIC microcontroller, only you will change the pin configuration in the actual hardware setting. Then you will only reinitialize the pin. Rest of the programming will remain the same. So guys, let's recheck. C0 for RS, EN for C1, D4 for C2, D2 for D5, D6 for D3, D7 for C4. That's all. Now guys, do the same here. That was for the pin layout, and this is for the pin direction. For RS, we have C0. For EN, we have C1. For D7, we have C4. For D6, we have D3. For D5, we have D2. For D4, we have C2. Let's recheck. C0, C1, C4, D3, D2, C2. Okay, that's all. LCD pins are initialized. Now we initialize LCD. Click on LCD INIT, and below that, in the example again, we have this command LCD INIT. You copy it and you paste it in the void main, and give some initialization delay like this. Delay MS 100 will do fine, like this. Now guys, LCD is initialized. Now we will need to initialize the ADC pin, because the sensor will be connected on the ADC pin. For that, expand the ADC library, and in the ADC library you have this ADC INIT command. Double click on it, this command, and you copy it and paste it below the LCD initialize command like this. Now all the ADC pin of the PICs are initialized like this. Now guys, we have an LED at D0. We write trace D.F0 equals to 0. It means that, like in case of an Arduino, you write pin mode output. So 0 means it's an output. And initial state of the LED, that initially, like you write digital write low, so we here write equals to 0. That this is, we had declared the pin mode, that pin is the output pin because it's 0, and now we initialize the initial state of the LED, that initially the LED must be off. Give some initialization delay. 20 will do fine like this. Now guys, we go to the main loop. And we start doing the programming here. For that purpose, first of all, we will need to read the value from the ADC pin. For that, we will need a variable. We take variable temp and we give it a float, like float temp. Then write down temp equals to ADC read 0. It means that float temp will read its value from the ADC channel 0. If you are using different ADC pin, then you will write different number, like if A1, then it will be 1, rest will remain the same. Now give some initialization delay. I give delay maximum of it will be 50, will do fine here. So 50. So this temp will store the raw value from the sensor, that from the channel 0, because I had connected sensor to the AF0. Now we will need to convert this raw data to the Celsius. To convert it to the Celsius, you have a standard formula. For that, you will need another variable which will store the value in Celsius. For that, write flow temp C. So temp C will store the data in Celsius. So for that, we use the Celsius formula equals to, so we write whatever the value received at the temp, the raw value multiplied by 5. This 5 is very important because it is a V reference value. I am using the 5 volt for the PIC. If you are using 3.3 volt, then it will be 3.3. It is a V reference, basically the value given to the voltage provided to the ADC module. So whatever you provide to the PIC goes to the ADC module. So I am using 5 volt for the PIC. It means you are giving 5 volt to the ADC module. So if you are using 3.3 volt, then you have to change the formula to 3.3 divided by 10. This is the standard formula for LM35 to convert the raw value to the Celsius. If your sensor do not give correct value, if you use this formula in Celsius, this means that your sensor is not original, because there are many copies in the market which don't work as per datasheet. So as per datasheet, this is the standard formula. Now guys, give some initialization delay. 10 will do fine. Now we also convert this temperature value to Fahrenheit. To convert it to a Fahrenheit, it's very simple. Again, take another float which will store the value in Fahrenheit. Write down FH, it means Fahrenheit. To convert the value into Fahrenheit, you will simply need to refer back to your physics book, and the formula to convert temperature in Celsius to Fahrenheit is that you convert the temperature in Celsius, multiply by 9 by 5. 9 by 5 is equal to 1.8 when you divide it, plus 32. This is the standard formula for converting Celsius into Fahrenheit. So we will simply use it. Now we give initialization delay here like this. Now since we cannot display these two values, that is the temperature in Celsius and temperature in Fahrenheit, directly on the LCD, we will need to convert them to a string. So for that, we initialize strings. Write down char temp C1 4. An array of 5, like maximum 5-digit string can be stored in this, and then do it for the Fahrenheit as well, FH1, like this. Now we go to the right. In the conversion library, you have a command called float to string. Look for it. This float to string fixed length, and this fixed length command is available on the newer version of the MIKROC. This is not available in the older version, so I suggest you use the newer version because it's very good command. So you first of all write it down. You will need 2 times, one for the Celsius and one for the Fahrenheit. Now here you will write the value which is to be converted, like this, the float, and in what it is to be converted, in this. This will store the value in string. Now the length should be 4 is enough. Now do it for the Fahrenheit. This is the Fahrenheit, copy it. Now Fahrenheit is to be converted into this string. This string will store the value whatever was in the Fahrenheit, like this. Now give initialization delays, like this. Now guys, we will display this to the LCD, but to display this to the LCD, you will have a problem of cursor. First of all, we will remove the cursor. We don't want the cursor. If you want the cursor, you can keep it. This command will clear the screen. So we place it, LCD clear command, like this. You place it here. So for the first run, it will clear the screen. Now place it again. In this, we will remove the cursor. For that, go back to the LCD CMD command. Here in the table, in variable LCD command, you look for LCD cursor off, this command. You copy it and you paste it within this bracket, like this. Now this will turn off the cursor. Give some initialization delay for both LCD cursor off and LCD's clear screen as well. It's a good practice to clear the screen one time when you run the code. So if there are any rackback values, they will get cleared. Now we go to the right and LCD, we double click on the LCD out command. Here you have this command. You copy it and you go back, you paste it below here. Now this is the row. Start writing from the first row, first column. What it should write? Temp C equals to that temperature in Celsius. Start writing from the first row, first column, and again copy this command. Count the digits here: 1, 2, 3, 4, 5, 6, 7, 8. So start writing from the first row and ninth column what temperature, whatever the temperature in Celsius is calculated by the PIC. Here, like this. Now give some initialization delay. 30 will do fine. Again do the same for Fahrenheit. Now here it will be F, and we will start writing from the second row, first column, and second row, ninth column. What we should write? FH1, this one. Now this is storing the value in Fahrenheit like this. Now guys, this is it. We have the code. We build it and see, look for errors. There is no error. So we burn it into the microcontroller and see what happens. So let me zoom out. So open this PIC16 programmer tool, select the microcontroller PIC16F877A, click import, and this is the code we have. I click on write. The code is being written. I go back to the hardware and see. Let me zoom out. Okay, the new code is being written. Okay, it's read. We power up the PIC using this PIC3. I click on. Let me zoom in. You can see that we are getting the values, but in the second row, in the extra digits, we get some ragged back values, and also in the first row, we need values still here. So we will rectify this LCD. So count the digits: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Till 12 it's fine. After 12 we need to remove rest of the values. We don't need it. So you go back to the programming and you rectify the code. So you write down here above this 2, 12, just make it empty. 1, 2, 3, okay, 12, 13, 14, 15, 16. Okay, that's all. You place it here. Also that you will place it after it. Do the same for the row. This was for the row 2. Do the same for the row 1 as well. Above it and below it. 1, 112. Now this is it. We build this code and burn it. It's already selected. Click on write. Okay, the new code is being written. Let me zoom out and get to the hardware. Okay, you can see that we did manage to rectify the code, but we removed so many digits. We have to get the 12th digit back. Okay, let's get the 12th digit back. So we simply do is that we make it 13. Okay, start removing the ragback value from 13 like this, and you remove one here so it don't overflow, otherwise the stack may overflow. Make it 13 and remove one. That's all. Build the code, write it. Okay, the new code is being written. So guys, you can see now this is perfect. See, this is the temperature in Celsius and this is the corresponding temperature in Fahrenheit. Now guys, we are getting our temperatures very nice. Now let me hold the sensor and see what is the difference it brings. So this is the sensor here. I try to warm up the sensor by holding it with my fingers. See, the temperature start increasing because the heat of my hand is being transferred to the sensor. You can see that it's increasing. Now I take this 29 as a threshold for the LED. We need to program the LED as well. So we go back. Now what I do is that I had taken 30° as a threshold, that whenever the temperature goes above 30°, it will turn on the LED. So for that, I will take this temp C. If temp C is greater than 30, okay, I make it 29. Then whatever it does, it will turn on the LED. Port D.F0 equals to 1 because LED is at port D.F0. Now else LED will remain off. It will only turn off if when it goes above this value, like this. I make it 0 here. So whenever the temperature will go above 29°, then it will turn on the LED. So I build this again. Let's see the LED works or not. I write this code. Let's zoom out and go to the hardware. The new code is being written. So let me reconnect the Wi-Fi as well in the meantime. Okay, let's check the LED. Now let me show you the LED. So you can see the LED as well now. So you can see that temperature here is 26. Now let me hold the sensor. See that whenever I hold the sensor, temperature goes up and the LED blinks. See that I am holding the sensor, temperature is going up. See, LED turns on because temperature is above the value specified. Let me reconnect the Wi-Fi. You can see that it's at 26.9. Now I hold the sensor. See, it's going up because heat from my hand is being transferred to the sensor. When it will go above 29, the LED will turn on. So it's not hand is cold. I hold this with the other hand. See, it has not turned on at 28. See, only it turned on at 29. Now it has reached at 29 and it has started turning on. Let me reconnect the Wi-Fi. See, it's 28.4. I increase the temperature by holding the sensor. See, it is going up and the LED is blinking. Whenever it goes up, LED blinks. See, it's about 29, the LED is on. Now it's down. I had left the sensor. I again hold the sensor. Now see when it goes above. See, it's about 29. I am holding the sensor. The heat from my hand is being transferred. So LED is on. Now I leave the sensor. Now temperature will fall. When it falls below 29, LED will turn off on auto. See, LED is off now. You can see that. In this way, guys, you can make various projects with this sensor, and you can also display the value, especially for safety, like in power supplies as well. You buy from the market, there is this sensor as well. Whenever the temperature goes above, it auto turns on the fan. It has a very good application in cooling system. That fan should be auto turned on and off whenever the temperature goes above or below, like in your room AC, air conditioner, etc. So I hope you guys learned something from this video. Thank you very much for your time and have a nice day.